Quality control is an essential operation to ensure that the product and service are safe, reliable, and meet the necessary standard. Definition of semi-solid dosage form. Semi-solid dosage form are the typical dosage form used for therapeutic, protective, or cosmetic function. It may be applied to the skin, nasal, vaginal, or rectal cavity. Advantages of semi-solid dosage form. If used externally, the probability of side effect can be reduced. First pass gut and hepatic metabolism is avoided. Local action and site-specific action of the drug on the affected area. Suitable dosage form for better drug, more stable than a liquid dosage form. Disadvantages of semi-solid dosage form. The accuracy can't be measured for semi-solid dosage form. May cause staining. They are bulky to handle. Application with finger may cause contamination. Physicochemical is less stable than a solid dosage form. May cause irritation or allergy in some patients. Ideal properties of semi-solid dosage form. Smooth texture, elegant in appearance, non-dehydrating, non-gritty, non-greasy and non-staining, non-hygroscopic. We have two types of semi-solid preparation. First one are creams. Creams are a semi-solid emulsion that contain fully dissolved or a suspended drug substance for external application. It's containing one or more medicinal agent dissolved in either water oil or oil-water emulsion. An example of oil-water cream is hydrophilic ointment, and an example of water oil cream is called cream. Then we will talk about ointment. Ointment are semi-solid preparation intended for external application to the skin or mucous membrane. Ointment may be medicated or non-medicated. Non-medicated ointment used for the physical effect that they provide as a protectant, emollient, or a lubricant. Raw material, a general term used to denote starting material, reagent, and solvent intended for production of intermediate or active pharmaceutical ingredient. A wide range of raw material is available for the preparation of semi-solid dosage form. Semi-solid dosage form are a complex formulation having a complex structural element. Mostly, they are composed of two phases, one of which is continuous external phase and the other is dispersed internal phase. The active ingredient is often dissolved in one phase, but sometimes when the drug is not fully soluble, is dispersed in one or both phase, creating a three-phase system. In-process quality control test. They are tests carried out before manufacturing process is completed to ensure that established product quality is met before they are approved for consumption and marketing. The physical properties of dosage form depend on a various factors. First, size of the dispersed particle, the interfacial tension between the phases, partition coefficient of the active ingredient, rheology of the system, viscosity. Factors that affect on a product characteristic and quality. First, temperature during the production process. Range of temperature during process is critical for successful manufacturing. Very high temperature may cause chemical degradation, which will affect product quality and stability. Second, shearing and mixing. Determination of type of shear and the optimal mixing time, method, and speed have an effect on the product quality. Proper mixing speed for each phase at every batch is very important for achieving desired characteristic of the formulation and high quality product. Third, flow rate. Important things during manufacturing of semi-solid dosage form. Optimizing flow rate involves determining the amount of a shear or a throughput needed. Raw material disperses in a line homogenizer require a proper flow rate. Finished product quality control test. We have a number of tests to check the quality of finished product. Let's start with the first test, which is physical appearance test. Main features to be checked here are color change, crystal growth, cracking of creams, viscosity change, development of a lumpy and granular appearance. Factors affecting physical appearance: incompatibility, temperature, microbial growth, and packaging. Then we move to the second test, which is particle size determination test. Procedure: dilute a suitable amount of the preparation with the same amount of glycerol or paraffin oil. Distribute a small amount of the sample on a glass slide and show under microscope. Count the particle with diameter below or above the specified by monograph. Compare with the accepted percent limit. Now we move to the weight variation test. Procedure: select 10 filled container and remove the labels. Clean and rinse the container from outside and weigh individually. Remove the content by cutting the container and washing with suitable solvent. Dry and weigh each empty container together with its corresponding part. Calculate the difference between the two weights. Net content equal to total weight minus weight of empty tube. Calculate the average weight of content. Weight of a 10 tube divided by a 10. Acceptance criteria: the average for 10 container should not be less than the labeled amount. If the labeled amount is 60 gram or less, the net weight of a known should be less than 90% of the labeled amount. If the labeled amount is more than 60 gram but less than 150 gram or more, the net weight of a known should be less than 95% of the labeled amount. If it's fail, weight another 20 additional container and determine average weight of 30 tube. Net average weight not less than the labeled amount. Content of a not more than one container out of 30 should be: if the labeled amount is 60 gram or less, net weight of a not more than 1 should be less than 90% of the labeled amount. If the labeled amount more than 60 gram, net weight not more than 1 should be less than 95 of the labeled amount. Viscosity test. Viscosity of semi-solid is a measure of resistance to flow. Apparent viscosity should be tested at the time of batch release and initially at a specific time point to test for stability. Viscosity can be measured by Brookfield viscometer, cup viscometer, cone plate viscometer. Consistency test using gravity-driven measurement method. Procedure: place the test sample on the base of the penetrometer. Bring the temperature of the penetrating object to 25 plus or minus 0.5 Celsius and then adjust its position such that its tip just touches the surface of the sample. Release the penetrating object and let it to descend for 5 seconds. Clamp the penetrating object and measure the depth of penetration. Sterility test. Test that critically assess whether a sterilized pharmaceutical product is free from a contaminating microorganism. Criteria: if the number of items in the batch not more than 200 container, minimum number of items to be tested 5% or 2% of the container. If the number of items in the batch more than 200 container, minimum number of items to be tested is a 10 container. Rate of a drug release test. General method: Small amount of ointment is placed on a surface of a nutrient agar contained in a petri dish. After a suitable period of incubation, the zone of inhibition is measured and correlated with the rate of release. An alternative method is to smear the internal surface of test tube with a thin layer of ointment. Fill the tube with a saline serum and after a gap of time, estimating the amount of a drug present in a serum saline. Specific method: vertical diffusion cell apoptose, immersion cell apoptose, flow through a cell. Vertical diffusion cell apoptose, composed of a 6-cell unit. Each cell consists of 2 chambers, donor and receptor chamber, separated by a membrane and held together by a clamp or screw-top in the donor chamber. The semi-solid dosage form sample set on a synthetic, inert, highly permeable support membrane. Sampling generally is preformed over a 4 to 6 hour time period. The receptor medium must have a high capacity to dissolve the drug, and the drug concentration in the receptor medium at the end of the test ideally should be as low as possible. The thickness of the sample chamber normally is 1.5 mm. The glass support disc is used to occlude the semi-solid dosage form. A receptor cell mixer and stir magnet are used as an internal stirring mechanism. Spreadability test. Spreadability test is used to measure the ease of spreading on the skin. Procedure: spreadability glass slide apoptose is used. 2 glass slides are used. The lower slide is kept fixed while the upper slide is movable and a band attached to it. 20 grams of dosage form is placed between the 2 slides. The spreadability is measured by time taking of 2 slides to slip off from the dosage form. Lesser the time taking to separate the 2 slides, better will be the spreadability. Rate of penetration test. Weigh the quantity of the preparation should be applied over a selected area of the skin for a defined period of time. The preparation left over is collected and weighed. The difference between initial and final weight of the preparation gives the amount of a preparation penetrated through the skin, and this, when divided by the area and time period of application, gives the rate of penetration of the preparation. The test should be repeated. Non-irritancy test, to evaluate any potential of dosage form from the skin irritancy. Procedure: about 9 cm, 2 area of the rabbit skin is shaved and then 1 gram is applied on the shaved area. Observed for 7 days for the development of erythema, redness and edema, swelling. Acceptance criteria. Category: mild skin reaction, edges of area will defined by a defined tracing. Moderate, area raised approximately 1 mm. Severe, beet redness to slight scar formation, raised more than 1 mm and extended beyond area of exposure.